Sorry about not having class today. Um, let's go over some of the law of sines and law of cosines work that we were going to go over. So this will be available to you anytime you need it. And then we'll move on just a little bit more and cover what we had anticipated covering in class today. So I realized that the law of sines and law of cosines assignment was due today on the 28th, but I've extended it to the 30th, so that should give you time to watch this and practice before you have to do that assignment. And if you have any other questions, make sure you let me know before you take that open note quiz that's supposed to come after this. So we're going to do a problem of each kind. If we're looking at the law of sines, so this is a problem. It was given that I had a triangle CDE, and the only information I was given was that angle C was 70 degrees, angle E was 40 degrees, and side E is 17. So you'll notice that this triangle is not at all drawn to scale. I just needed a picture so that I could get a visual as to where this information was. So remember that angles are capital letters and the sides are lowercase letters, and the sides that correspond to the angle is opposite. So if this is angle C, this is side C. If this is angle E, across is side E. And if this is angle D, then across we have side D. So let's go ahead and label what we know. We know that C is 70. We know that E is 40. And we know that side E is 17. Now we're dealing with a triangle, so even before I start doing anything with any kind of law, typically the directions on these sections say solve for the missing parts. So we need to find all these missing pieces. Anytime we're dealing with a triangle, whether it's a right angle or not, all of the angles have to add up to 180. So if we add these two together and subtract from 180, we should see that angle D is also 70 degrees. Now, that tells us something important. Angles that are congruent are opposite of sides that are also congruent. So these two sides are the same, and I should mark that angle 40 with a different mark. So this one's different, but since these two angles are the same, then these two sides that are opposite them are going to be the same. So this is going to really simplify this problem for me, because once I have one, I already know that I have both. So remember that our law of sines, if you look back at those notes, or if you've already memorized it, it's sine of an angle over its side is equal to sine of whatever other angle over its side is equal to the sine of whatever angle is going to be E over its side. So these ratios are always going to be equal to each other. The sine of the angle over the length of its side, all of those proportions are going to be the same. Now we can always flip it over. Sometimes you'll see it as the side on top and the sine on the bottom. That's fine. As long as we're consistent, you might see it one way or the other. Now I know that I have a full ratio when I have E and E, the angle and the side. I know that I'm going to be able to fill in this whole thing. And I also have this C and this D. So the only thing that I'm looking for are these two sides. So let's fill in what we know. I'm just going to do this for this part of our ratio, since I've already figured out that this value is going to be the C and the D sides are going to be the same. So let's look at sine of angle D, that's 70 degrees, over D is what I'm looking for, equals sine of 40 degrees over 17. Now there are a couple ways that we can simplify this. Hopefully the algebra part doesn't throw you off too much. We can type this whole fraction into our calculator and then solve for D, or we can go ahead and cross multiply from here. I'm going to type this in for you really quickly just to make sure that you know what we're looking for. So looking at your calculator, hopefully we don't have a glare, there we go. Looking at your calculator, if you go to Shift and Menu, that takes us to the setup. Now all of the angles are given in degrees for this section, so make sure your angle setting is on degree, and since it is, then we're okay. So we're going to exit out of that, and we want the sine of 40 degrees over 17. And I'm just going to go ahead and simplify that fraction. Oh, I added in a. So since we're dealing with measurements on this one, decimals are going to be okay. I know a lot of times we discourage that, but for now it's going to be fine. And I would keep 4 decimal places as you do your work on these. So now I need to multiply this side by D to get it out from under the bottom. And then I'll be dividing both sides by 0.0378. Okay, so just switching that around so I'm getting the D all by itself. So this is going to be sine of 70 divided by that previous answer, so 0.0378. Ooh, not like that. So the length of D is 24.86 if we round that decimal. And we know that the way it's set up, that's also equal to side C. So both of these pieces up here that we were looking for are going to be 24.86. And now we know all of the components of that triangle. Okay. Now, if you look at the examples that I gave you, for any example that we're looking at, that one was kind of a special case where 2 of the legs were equal, so that's not always going to work out that way. For this one, I was given this angle M and side M. So anytime I have an angle and a side that match up, I can use the law of sines. Let me say that again. Anytime I have an angle and a side that match up, I can use the law of sines. So since I have angle M and side M, I can set this up with angle M and side M to complete this one side of my ratio. So I can use it to find angle P, and I can use it to find side N. So using all of these pieces to fill in those missing blanks. So I had these 3 pieces of information in the beginning, M, and side P, and I was looking for the remainder of that information. So first, I'm going to complete this and find out what angle P is. So notice I put sine of M over M is equal to sine of p, which I didn't know yet, over side p. So when I solve this one, it's a little bit different. We have to cross multiply. So 19 times the sine of 44 degrees is equal to 30 times the sine of p. So what we need to do is, I went ahead and cross multiplied here and got 13.1985 is equal to 30 times the sine of p. Now I need to isolate the sine of p so I can finish this up. So I need to divide both sides by 30, which I did. And that's what I get is 0.43995 is equal to the sine of p. Now the opposite of sine, we call it arc sine. So whenever I'm trying to solve an equation, I do the opposite on both sides. So if I do the inverse of sine, that's this sign or this symbol that's on your calculator. So if you press shift and the sine key, then it brings this up. And that cancels out the sine on this side. So we end up with finding the angle P is about 26 degrees. So now I have 44 degrees, 26 degrees. I know I'm dealing with a triangle and they have to add up to 180, so that last one is 110 degrees. I like to go back to the complete fraction that I had to start with, that sine of 44 degrees over 30, to find that last side. So we've got sine of 110, that's n, over little n, because we're going to find that side length. So just like the one I did on the previous page, we're going to cross multiply here or simplify this fraction. And when you solve that out, that one's not quite as cumbersome. So we're going to have n is equal to about 40.58. So again, we're dealing with measurements of angles and sides. And in this case, we're going to be dealing with decimals, and that's okay. The next part of your notes talked about the law of sines. So when we look at the law of cosines after the law of sines. So this one's a little bit more complex. The formula for this one looks like n squared equals p squared plus q squared minus 2pq, the cosine of n. So that's what the formula looks like. And this could be with any triangle, but in this case, we're looking at a problem where our triangle is called NPQ. So whatever side our formula is equal to, that's the angle that we're looking for. Now notice before I said as long as I had a side and an angle that matched up, that I could use the law of sines. In this case, I have 3 sides and no angles. So we're going to have to use the law of cosines to find one of those angles, and then we can use a more simple method to find the other pieces. So let's go ahead and work this out. So this is going to be 35. Again, this is not at all obviously drawn to scale, but just so that we can get an idea of where those are located. So side N, side Q, and side P would fall in those locations. So let's fill in what we know. We know all of the lowercase letters, we know all of the sides, and we're looking for that angle that's right there. So let's plug these in and see what happens. Okay, so that's what happens when we plug all of those pieces in. Now let's simplify it so that we can solve for the missing piece. So from here, we have to be really careful about what order we simplify things in. Obviously, we can go ahead and square these pieces. So this will be 1225. And I'm going to go ahead and combine 2 parts at once. So I'm allowed to add these two together. You could do this in two separate steps, but 11 squared plus 25 squared, we can put those together at one time. So this is going to be 746. And then I can put this minus 2 times 11 times 25 together. Now this is a coefficient of this cosine n, so I can't put all of these parts together because this is the coefficient of this cosine term. So when we put that together, we'll have minus 550. So you have to be really careful about the order. Now we're going to subtract the 746 from both sides. It's going to give us 479 equals negative 550 times the cosine of n. So if we divide both sides by negative 550, that's going to give us something kind of weird right here, but it'll work out in the end. This is going to be negative 0.870909 when we type this fraction into the calculator. And remember, we're looking for measurements, so it's okay if it's a decimal here. So we're left with cosine of n. Now remember, to get rid of a trig function, we have to do the inverse. So the inverse of cosine is the arc cosine. So basically, we're going to take the opposite of cosine on both sides. And this is what it looks like when we type it into the calculator. So the opposite of cosine times cosine, that's like saying 1/5 times 5. And it cancels out. So this cancels out and we're left with just n on this side. So we're going to find out what that n is. And if we type this into our calculator, remember we want our answer in degrees, so make sure it's still in degrees. It won't change itself, and since we're doing this all at one time, and then it's fine. But if you switch to another assignment and then come back to this, just make sure that it's in the right form. So if we do arc cosine, so shift cosine, and then type in that decimal, we should get 150.56 degrees. Now that's one angle. So I found one angle. I'm looking for all three angles. I honestly don't want to go through the law of cosines again because that's a lot of work just to find one measurement. But now, if you pay attention, we have this angle and this side that creates a full ratio if we look at our law of sines. And then we can find either angle P or angle Q from that. I'm going to choose P just because it has a smaller value. I don't know. It looks convenient to do. So here to the side, I'm going to find that other piece. And actually, I already have it worked out, so I'm going to show you that process. So this is what it looks like when I use the information that I have here. Angle N goes here. Side N goes here. I'm looking for angle P, so I'm going to leave that P in my problem. And then side P was one of my given values, and that's 11. So this goes back to the law of sines problems. So we can cross multiply or simplify the fraction. You can see here that I've already, I simplified the fraction and multiplied by 11 kind of all at one time because I was trying to get that sine P part by itself. So when we do sine of 150.56 divided by 35 and then multiply by 11, we get this decimal. And then we have to take the inverse of the sine so that I can get the p part by itself. And it tells me that that angle has a measurement of 8.89 degrees. Now, I have two pieces. I have two of my angles. So this angle is 8.89 degrees. If I'm dealing with a triangle, all three of these angles have to add up to give me 180. So using what I know about triangles, I know that this final angle is going to be 20.55 degrees. And you don't have to round to the nearest hundredths place. I did here just because there were a lot of decimals going on and I wanted it to be as close as possible. If you round to the nearest whole degree or the nearest tenths place, it'll be just a little bit different. And that's okay, we account for that. So that's our answer for if we're going to use the law of cosines for a problem like this. So notice, if we're going to use the law of sines, we have to have a ratio that matches up. So I have to start out with an angle and a side that I know that match up together. So they're across from each other. I knew angle E and side E to start with. So I was able to find those other missing pieces. When I'm looking at the law of cosines, I didn't have a pair to start with. All I had were all of the sides, which was great, but I had to find an angle. So when we find an angle, make sure you go back to that law of cosines. Okay, so remember, the side that it's equal to and the angle that we're looking for, or the angle that we have, those two pieces always match up. And this PQ, that just matches the triangle that we're dealing with. If you notice the ones in your notes where I show you where the law of cosines comes from, I did it with A, B, and C. Okay. So hopefully that clears up the law of sines and law of cosines portion. If you have other questions, I'm going to go ahead and post this video so that you'll have it to go by. If there are other questions on any of these sections, please feel free to let me know and I'll post new notes shortly. I want you to be able to do that open note quiz before we go into something new. So make sure you get all of those things done and submitted. You can take pictures and turn them in, or you can type it in a document, but that's a little bit harder. So pictures of your work are fine. Just make sure I can read it.